You know, back in the 90s, we had this thing called alternative rock, which was basically anything except 80s new wave music or hair band arena rock. Well, today, anything other than the traditional application development approach or waterfall approach is called alternative. Let's check it out. In Systems and Infrastructure Lifecycle Management Part 2, we're going to do just what I promised. We're going to look at alternative methods from the SDLC, or Waterfall Application Development. Then, we'll look at infrastructure development and acquisition, information systems maintenance methods, tools and other aids, and then finally, process improvement techniques. You know, information systems and IT systems and security have become much more complex in the enterprise organization with the convergence of the network infrastructure with all the business and application processes that sit on top of it. Refer back to that SONA diagram I showed you earlier in this Nugget series. So new methods have been developed that allow for more flexibility and for more quick change in organic organizations. Some of these new approaches are radical departures from the traditional waterfall model that we looked at in the previous Nugget movie. It's rapidly being replaced with some revolutionary thinking. Now, as an information systems auditor, you don't have to know how to use all these different systems, but you need to be aware of the system that's being used by the organization that you're auditing. Number one, you want to make sure that they're using some type of system. Number two, that it's effective, and maybe an understanding of other possible solutions or alternatives that you could offer as an IT consultant. As an auditor, you may encounter things like incremental development, where a system is built in stages or small releases instead of being delivered in its entirety in one implementation. The separate releases are still large projects, but they're discrete sub-projects. Typically, you release the first basic system architecture in the first release, and then subsequent releases will expand on that basic system architecture. Another method is iterative development. This, of course, involves building your system in iterations or incrementally, getting feedback all along the way to facilitate any necessary adjustments or changes to the project plans or software development. As a matter of fact, iterative development or agile development that we'll look at here in a minute are really considered to be some of the best practices nowadays. Now, really, if we look at these other options, evolutionary and spiral and agile, these are all basically extensions of the iterative process. In evolutionary development, prototyping is used to build a working model that's used to verify the requirements and needs and explore design issues. Eventually, that prototype gets hardened and then put into production. Spiral development is a series of prototypes used to find a solution. Spiral development basically spirals out from the initial limited prototype to become increasingly more expansive and complex and detailed. Before each prototype, you have formal risk analysis. And the final extension of iterative is agile development. Let's go ahead and talk about this next. Agile development, or agile development, depending on where you're from in the country, began with Scrum, in the 1990s, and it's led to newer developments in application development, extreme programming, XP. I'll show you the website here in a little bit, Crystal Reports, adaptive software development, and others. One of the fundamental things that Scrum did was it moved the direction and the planning tasks from the individual project manager to the team, where the project manager is now more of a facilitator, somebody who removes obstacles, helping them achieve their objectives. Let me show you some of the websites for these different agile development products. Here's extremeprogramming.org. You can check this out. Kind of gives you the simplistics of XP, not XP like Microsoft's XP operating system, but extreme programming. They've got a full-size diagram here that you can kind of go through the process and see how it works. Again, understanding the ins and outs of all these different application development projects is not important for the exam. It's just being able to understand as an auditor that your organization must be using something. At businessobjects.com, you can find the Crystal products, again with Crystal Reports Developer and Crystal Reports Server, which is what we call kind of a rapid development application program. You can download some PDF files from them to get more information on Crystal. Jim Highsmith was the guy that really kind of pioneered the whole agile development and the adaptive software development. He's got his own website called adaptivesd.com. And I want to come up here and spend some time here and check this out, and you can add this to your favorites as well. The adaptive software development is really a software development process that grew out of the rapid application development work done by Jim Highsmith and another guy named Sam Baer. ASD replaces the traditional waterfall cycle by repeating a series of speculative processes, collaborative processes, and learning cycles. These dynamic cycles provide for continuous learning, continuous adaptation to the emergent state of the project. Characteristics of ASD lifecycle vary from the waterfall approach in that they're mission-focused, feature-based, iterative, and they use small, time-boxed sub-projects. They're also highly risk-driven and very tolerant to changes. With agile development, you'll do a reprioritizing of functionality at the end of each iteration or sub-project, and teamwork is highly emphasized. Some methods of agile have two people coding the same exact project simultaneously and then comparing the results from a team standpoint. As I mentioned earlier, the project manager is now more of a facilitator and a cheerleader as opposed to an autocrat. With Agile, only the next project coming up is really planned in detail. Like the name says, it's made for quick shifts in focus and design. Another alternative application development method that was spawned from the iterative process is prototyping. Prototyping is also known as evolutionary development or heuristic development. In order to reduce risk, prototyping uses managed trial and error techniques. This way, the developer and the client or customer can know and react to the risks at each evolutionary level. It basically combines the classic features of SDLC that we saw in the previous movie using a systematic stepwise approach, but incorporating iterative frameworks that more realistically reflect what's seen out there in enterprise application development. Prototyping uses faster development tools, so you can see a high-level view of the outcome of the proposed system in a short period of time. Prototyping relies heavily on what we call 4GL or fourth generation programming languages. These are non-procedural languages that are used for relational database queries, report generation, manipulation of data, manufacturing a graphical user interface, and configuration management. In other words, they're designed with a specific purpose in mind, like, for example, what we're looking at, commercial business software and application development for the enterprise. 4GL languages are more effective for software engineering and problem solving and systems engineering. You see these languages often creating report generators, form generators, and used in database query languages like Informix 4GL, SQL, and others. There's two main prototyping approaches. The first approach is where you build a model to create your design, let's say for an inventory tracking software for your enterprise. Then, based on that model, you're going to develop a system design that has all the performance features, all the quality and maintenance features built into it. The second method is to gradually build your system to operate in production using one of these fourth generation languages that are best appropriate for the system being built. You've got these 4GL languages for general use, database, reporting generation, data manipulation, analysis, and reporting languages, data stream, screen printers and generators, and creating GUIs. Cold Fusion, maybe you've heard of that, or Power Builder, those are really good examples of production suites that are used with this type of alternative business application development. Prototyping goes hand in hand with what we call rapid application development, or a RAD approach. Let's take a look at the RAD methodology. RAD, or Rapid Application Deployment, is a software development process, an iterative software development process that was developed by James Martin. RAD is going to use prototyping as its core development tool or process regardless of the underlying technology, and realize there are a bunch of products and technologies out there that use this rapid application development process. And that would be a wide variety of case tools. RAD was a response to the non-agile processes that were developed in the 1970s, such as the SDLC waterfall model. RAD was developed in the 1980s by James Martin. Again, it uses iterations, prototyping, and computer-aided software engineering tools. RAD does make compromises for end-user usability, for feature sets, and execution speed. RAD places a greater emphasis on simplicity and GUI usability. It's going to deploy small, highly trained development teams and a central repository of data, with change management software included. RAD places rigid limits on development timeframes, hence the word rapid application deployment. The fundamental RAD methodology has four main stages. First of all, you have the concept definition stage. This is where you're going to define the business aspects, the business functionality, and data subject areas that the system is going to support. It's also going to determine the scope of the system or the application. Next is the functional design. This is where you use teams and workshops to model the system's data and the different processes to build that working prototype of the critical system component. Then development is the stage that really finishes off the construction of the physical database and the application system. It builds in the graphical user interface, user aids, and deployment work plans. And then finally is the deployment. This is the final user testing, end-user training, data conversion, and full-blown implementation of the application system. You might want to check out blueink.biz. You got web applications instantly. It just kind of gives you some frequently asked questions over here, some basic questions. If you're not a programmer, what is a web application? What is code generation? You can go view a demo, take a tour of the site. You can see how they advertise cost savings in using their rapid application development solution, Blue Ink. Add this to your favorites and come check it out. As I mentioned earlier, as auditors, it's our job to make sure that the organization is using efficient and effective cost-saving application development methods. That being said, you need to be aware as an auditor of other popular alternative application development processes. We're going to look at 5 categories right here. The first method is DOSD, or Data-Oriented System Development. This approach basically focuses on data and its structure. Companies like service providers, airlines, telcos, stock exchanges have to generate a lot of time-dependent data. So DOSD gives them a data transformation process that is resistant to errors. It makes portability, conversion, transcription, and transposition much easier. Typically, DOSD is combined with other development techniques to develop effective business solutions. OOSD is an object-oriented process where data and procedures are grouped up into entities known as objects. The object's data is referred to as its attributes, and its functionality is referred to as its methods. Object-oriented is really contrasted to the traditional structured SDLC approach, which basically considers data separate from the procedures that act on the data. It's important to realize that OOSD is a programming method and not really a software development application methodology. Java is a prime example, and applications that use object-oriented technology are things like web applications, e-business, e-commerce, CASE, C-A-S-E, we talked about earlier, for software development, automation programs, artificial intelligence, and computer-aided manufacturing. A third popular method is component-based, and a lot of different technologies fall under this umbrella. DCOM, Corba, RMI, Microsoft Transaction Server, EJB, Enterprise, Sun's Enterprise Java Beans. This is really an outgrowth of the object-oriented development process. Basically, you assemble applications from cooperating packages of executable software that make their services available to other services through defined interfaces, or objects. Component-based application solutions can be in-process client components, standalone client components, standalone server components, like DCOM and Corba, and in-process server components. That would be Microsoft's Transaction Server and Sun's Enterprise Java Beans. XML and SOAP, XML being Extensible Markup Language and SOAP being Simple Object Access Protocol, are web-based technologies that are also used to deliver application development. This is a huge area in application development because web-based apps don't use remote procedure calls like Corba and COM do. They take advantage of HTTP and other protocols used in the World Wide Web. And then finally, another method is reverse engineering. This is the process of taking an application apart and seeing how it works, and then use that information to develop a similar system. This can be done by decompiling object or executable code into source code and then using that to analyze the application. Or you can utilize the reverse engineered program as a black box test and then unveil its functionality for using test data. From the auditor's standpoint, another key aspect of infrastructure lifecycle management is making sure that there's a process in place for developing the present infrastructure and acquisition of new systems, new hardware, and new software. As an auditor, you need to make sure that there's something in place to analyze the present infrastructure so that it can lead to new technologies, new designs, better procedures, an ongoing process of training, as well as installations and deployments, and basically reducing the total cost of ownership. The entire infrastructure development and acquisition program should be under the umbrella of ongoing business continuity and disaster recovery. This will also include upgrading legacy hardware and software and converting data and translating data to new database systems, to new information systems, and preparing for migrations or mergers and acquisitions. Also in this category is providing for 24/7 availability. What are the goals of this development and acquisition process? We want to reduce costs. We want to increase the profitability of our organization, improve the overall functionality and experience for the end user, minimize the impact of any acquisitions and changes, deliver the 3 keys of security: confidentiality, integrity, and availability, and provide a fluid, progressive migration implementation process. As an auditor, you want to make sure that the suggested solution makes sure that you have alignment with the corporate standards and business needs, provide proper levels of security, integrate with current IT and IS systems, look at the forward trends of the industry, provide operational flexibility for the future to support all business processes, allow for projected growth without major upgrades when possible, maximize the return on investment, provide for the usage of standardized hardware and applications, and just basically make sure that you have cost-effective day-to-day operational support. From a project management standpoint, there's 6 phases to the analysis of physical infrastructures. First of all, you'll review the existing infrastructure, study the latest documentation, workshop all the different functional areas, learn the current infrastructure, and also know the constraints that prevent you from growing in certain areas. The second step is analysis and design, reviewing the architecture and then designing the actual physical architecture and comparing that against the best practices and the needs of your business. The third step in the analysis is to draft a functional requirement. This is basically the first rough draft of functional requirements. This is going to be a key aspect of the next step, step 4, where you develop the functional requirements with the vendors, with the in-house or outsourced solution. This may also involve consultants or auditors. In step 5, you'll define the final requirements. This is a functional requirements document introduced right before the final step, proof of concept, begins. Proof of concept is highly recommended. This is used to prove that the chosen hardware solution and software solution meets all the requirements, security expectations, and growth expectations. The deliverable should be a running prototype with associated documentation and technical specifications. Now, there are 4 steps to planning and infrastructure implementation. And let's say you're putting this together, let's say a Microsoft project, for example, or using a Gantt chart. It's very likely that these phases would have some overlap. But from a methodology standpoint, we need to understand there's 4 different phases. First of all, the procurement phase. This is where you establish the communication processes and get an overview of the selected solution. You're going to figure out the quantity structure of the physical deliverables. This is where you sign contracts and service level agreements. The second phase, which will obviously overlap procurement, is delivery time. This is where you set the priorities and the goals and the tasks to deliver the physical implementation, whether it be a security appliance solution, a web server farm, or perhaps end-user workstation rollout. The third phase is the installation plan. You're going to involve all the affected people, all the parties that are involved in this process. Review the plan with those parties and their team leaders, and get organized with the individuals responsible for integrating. This is an iterative process. And then finally, a test installation. This is where you determine the basic requirements, basic specifications. You'll define the process. You'll go through a pilot testing as much as possible. and you'll get measurable results for the application or the physical implementation and the network infrastructure. To make the implementation successful, you want to make sure that you have the right staff, trained individuals attending workshops and training and participating in the entire project from day one. Document all along the way to carry out the work necessary so that you can learn from your mistakes. Make sure the decision makers are involved in every step of the process, and don't forget about your management sponsor and steering committee. Make all the decisions as quickly as possible. Be prepared and meet your deadlines. Well, obviously, a big part of life cycle management for your infrastructure is acquiring hardware. As an auditor, you may need to monitor this process for quality assurance and efficiency. Some of the key issues around hardware acquisition are, first of all, understanding the type of organization that you have. So it's a client-server environment. Is it distributed? Is it an outsourced, insourced, hybrid environment, centralized or decentralized? Then, what are the corporate requirements for data processing? Real-time databases, client-server, batching, replication, those types of issues. Then just basic hardware requirements. Disk space requirements, memory, CPUs needed, the peripheral devices in use. Is it a retail outlet using terminals or point of sale terminals or ATM machines? What are the networking capabilities? Is it Ethernet, fiber? Is there a wireless network? This should all be well documented. Then what systems software applications are being used with the hardware? Again, software acquisition is a whole different category, but we need to know what type of software is running on these platforms. What type of versions of network operating systems and end-user systems do you have? Are there any upgrades or patches or fixes required? Do you use compilers or database management systems, communication software, access control software? What type of support systems are there? What type of ongoing training and technical staff is there? Do you have a help desk facility? What type of backups are being done? Disaster recovery plans, as well as the daily backups. What about adaptability and compatibility with existing hardware and software platforms? Are there any migrations coming down the pike? Are there any constraints like a limited staff or a limited budget or certain mandatory delivery dates? Mergers, acquisitions, transitions. And are there any conversion needs? Converting data, converting inventory systems, converting sales systems or database systems. All of these things need to be taken into consideration as you audit the hardware acquisition process. Evaluating software acquisition is also part of the systems and infrastructure lifecycle management process. First off, you want to evaluate the business needs that the software meets, the technical needs, the functional needs, and the collaborative needs that your organization has for software. And does the existing software solution meet those needs? Does it provide mechanisms for security and reliability? What are the costs and the benefits of the software as compared to the financial investment, the time for training, and the hardware that needs to be supporting that software? What's the likelihood of the software becoming obsolete in the next 36 months? Are there any risks to using the software? For example, does it have problems with system compatibility with other applications, or are there any known issues with network operating systems or end-user operating systems? Can you allocate the proper resources to implement the software solution? In other words, time, money, training, configuration management, security, and constant upgrades. Again, what are the training and personnel requirements for supporting the software? Do you have a need for scalability with a scalable software solution? For example, is it a front end to a back end database that has a scalable solution? Is it distributed software? Or are there limitations for growth? Or limitations if your company has a merger or acquisition? And of course, finally, what is the impact of the software on your present infrastructure? As far as maintaining your information system goes from an auditing standpoint, you want to approach this from two different directions: change management or modifications to the system, and configuration management. As an auditor, you want to make sure there's mechanisms in place for request for change documents, for testing and auditing of any changes to the information systems, for processes for emergency changes, and what individuals have the authority to sign off on changes. And how do you handle incidents for unauthorized change control? Are there policies in place in your security policy for dealing with enforcement? Many organizations deal with configuration management on a manual basis. They may have an administrator or several administrators who are in charge of managing configuration changes. Configuration on network devices like routers and switches, configurations on servers and end-user workstations, configuration files for directory servers and web servers and email servers. In larger organizations, however, you may have to use a configuration management system. For example, Windows 2000 and Windows 2003 both have what's called group policy, which allows you to do enterprise-wide directory service managed configuration management. Configuration management is going to involve processes throughout the entire software and hardware life cycles. You need to be able to identify, define, and baseline the software items in the system and provide a basis for any problem management or challenge management, change management, and releases of new software updates. Configuration management is crucial because software is always going to be changing on a regular basis, sometimes on a weekly basis, during and after the development process. You want to ID items that are likely to change on a regular basis, and once identified, hand the information over to your steering group or configuration management team to document the information, assign it a reference number, and put it in a database for future reference. This information can be used to create your change management configuration management baseline. Here's a list of several standardized documents that are used for documenting change management or request for changes and configuration. There's EC, engineering change. There's engineering change request, ECR. The engineering change order, ECO. Change notice at chemical, CNC. Action request, AR. Request for change, RFC, which is common in the ITL implementation and Prince2. So as far as auditors go, we'll be more interested in this one right here. And then of course CR, change request, is another common one used in change configuration and change management. Now I already referred to CASE and 4GL earlier in this Nugget movie, but before we finish up this movie, I want to revisit a few key points. First, looking at computer-aided software engineering, CASE or CASE involves automated tools. Tools that were used to collect, organize, and present large amounts of data at application levels, system levels, and the program level. A huge part of application development will be translating this information into actual program logic and code that can be used for testing, modification, and ultimately implementing the application solution. This is a time-consuming process, but it's important to be able to develop, use, and maintain computer applications. CASE is a set of automated tools that facilitates the software development process. CASE products are often divided into three different categories: uppercase, middle case, and lowercase. Uppercase products are used to describe and document business and application requirements. Middle case products are used to develop the detailed designs, like screen layouts, report layouts, editing mechanisms, data object organization, and process flows. Lowercase products are used to generate program code and database definitions. This involves programming rules and database syntax rules that generate program logic ultimately, as well as data file formats or even entire applications. CASE tools can be found for mainframe environments as well as mini and microcomputing environments. CASE tools enforce a uniform approach to system development. They allow for organized storage and document retrieval, and they automate the system design data. An auditor may even use a CASE tool himself or herself instead of just auditing and monitoring the tools that are used by the organization. Another powerful set of tools is the 4GL. These are fourth generation languages. 4GLs are non-procedural. In other words, they don't use a structured language approach. They're portable across multiple platforms and operating systems. They're software-based, and they're simpler to use. They're often referred to as programmer workbenches. There are several types of 4GL applications, like query and report generators that extract and produce reports. This is also known as audit software. There's also embedded databases. Examples of embedded databases that can be placed into appliances would be things like Focus, Ramis2, and Nomad2. There's also relational database 4GLs like SQL Plus and Mantis. And then finally, application generators. These tools generate lower-level programming languages like COBOL and C programming language. And once that's done, the application can be further customized and modified. Typically, data processing development personnel, and not end users, will use these application generators. As an auditor, you also want to be aware of the different process improvement techniques. There's 5 major techniques that I'm going to define for you here. First of all is business process reengineering, or BPR. BPR is a management approach that aims to improve by means of elevating efficiency and effectiveness of the processes that exist within your organization. Business process reengineering is also known as BPR, business process redesign, business transformation, or business process change management. For example, BPR has helped giant companies like Procter & Gamble and General Motors succeed after financial drawbacks due to competition. It also helped American Airlines get back on track from the bad debt it's currently experiencing. BPR is about the proper method of implementation. Next is ISO 9126. It's an international standard for the evaluation of software. This standard is actually overseen by the project called SQUARE, S-Q-U-A-R-E, or ISO 25000:2005, which uses similar concepts. The ISO 9126 standard is broken up into 4 parts, which address the following subjects: quality model, external metrics, internal metrics, and the quality in use metrics. It focuses on functionality, reliability, usability, efficiency, maintainability, and portability of the software solution. The Capability Maturity Model, or CMM, refers to process improvement approach. It's based on a process model. CMM is also a model developed by the Software Engineering Institute, SEI, in the mid-1980s. It's also a family of processes. The CMM can be used to assess an organization against a scale of 5 different process maturity levels. Each level is going to rank the organization according to its standardization of processes in the subject area being assessed. These areas can be as diverse as software engineering, systems engineering, risk management, system acquisition, information technology, this is where we're concerned, and personnel management. CMM was developed by the SEI at Carnegie Mellon University in Pittsburgh. CMMI is simply integration of the Capability Maturity Model. It's a process improvement approach that gives companies essential elements of effective process improvement. The latest version of CMMI version 1.2 came out in August of 2006. CMMI is adapted to each individual organization or company, which is appraised at a certain level of CMMI. The results of the appraisal can then be published by the appraised organization or a third-party auditor. And finally, there's ISO 15504, also known as SPICE, the Software Process Improvement and Capability Determination. It's a framework for the assessment of software processes developed by the Joint Technical Subcommittee between ISO and IEC, the International Electrotechnical Committee. In a nutshell, 15504 is not a set specific standard, nor is it a methodology. It's basically a list of activities that should occur in a software project. It doesn't set out the order in which the activity should be carried out either. It sets categories or pigeonholes in which the assessors can place the evidence that they collect during the assessment. Then the assessors or auditors can give an overall determination of the organization's capabilities for delivering software. Here's a sample flowchart of how SPICE, or ISO 15504, works. At level 0, the software application is incomplete. Either it's not implemented or it's failed to achieve its purpose design. At level 1, you have performance, or process performed. The process or software is implemented and it achieves its process purpose. Level 2 is managed. This involves performance management and work product management. The process is managed and work products are established, controlled, and maintained. At level 3, you have established. This is where the process or software is defined and deployed. Level 4 is predictable. The process or application is behaving consistently within defined limits. At this level, process measurement and process control occurs. And then the final level is optimizing, where the process or software is continuously improved to meet all relevant and applicable current and projected business goals. At the optimizing level, process innovation and process optimization occurs. In part 2 of Systems and Infrastructure Lifecycle Management, we looked at alternative methods for application development, infrastructure development and acquisition, information systems maintenance methods, tools and aids, and process improvement techniques. I hope this CBT Nugget's been informative for you. I want to thank you for viewing.